In this problem number 59, we're trying to simplify this, the square root of x to the 12th. Here's how I'm going to start this. I'm going to recognize that the square root really is this, right? It's a 2 here, x to the 12th. And now what I'm going to do is I'm going to convert this to an expression with fractional exponents. So I know when I make this conversion, I'm going to get x to the, now let's do this, 12 over 2, and where do these come from? Keep in mind that the index, the number in the corner, becomes the denominator of the exponent, and the power becomes the numerator. So this is going to be x to the 12 over 2, which we can write as the absolute value now, right? The absolute value of x to the 6th. But now we can actually get rid of these absolute values. We can eliminate the absolute values because we know that this is positive or 0, right? If x is 0, it's 0, but no matter what x is, x to an even power is positive, and the absolute value of a positive number is that positive number itself. So we're going to write this as x to the 6th. And now let's claim that that is our simplified form. But let me show you a way that we're going to use in the future, the next few sections. You see this 2 and this 12. What did we do here? The 2 became the denominator, and then we divided 2 into 12. So from now on, when I see something like this, when I see an index and an exponent, I'm just going to do that division directly. And when I do this one here, it's going to look like this. Let's do it this way. I'm going to take 2 into 12. Now, 2 into 12 will go 6 times with remainder 0. Now, here's what this means to us. We can pull 6 x's out, right? That's what we got here. We'll pull 6 x's out, and 0 x's remain under the radical. So when I write this, I'm going to write this now as x to the 6th. No x's remain under the radical, and again, because x to the 6th is always positive, we can write that as x to the 6th. So the idea is index into exponent, index into exponent. The quotient tells you how many to pull out. The remainder tells you how many remain under the radical. We're not seeing that here, but we will see it in some problems in a subsequent section. Well, now in this problem, we've got a base to some power, the same base to a power. So we're going to apply the rule of exponents, where we're going to write this base, 81, and then we subtract exponent, top exponent minus the bottom exponent. So it's going to be 9/8 minus 7/8. So we'll get 81 to the 2/8, or 81 to the 1/4. And now a couple ways to think about that. We can think about it directly as the bottom number, remember, tells us the root. So this is the 4th root of 81. So I think what I'll do here is, here's what we would maybe see in our heads. The 4th root of 81, and remember the numerator becomes the power that we raised this to. So it's really, here's kind of what you're thinking in your head. All right, that's in our brains. And now the 4th root of 81 is 3, and 3 to the 1st is just 3. Now this problem here, 65, this is going to be similar to 63 in this sense. In 63, we had a division, and in division, we subtract the exponents. Now we've got a multiplication, and in multiplication, we add the exponents. So when we do that, it's going to look like this. N to the 21/4 plus negative 5/4, or if you like, how about n to the 21/4 minus 5/4. That gives us n to the 21 minus 5 is 16/4, and that gives us 16 divided by 4 is 4, so that'll give us n to the 4th absolute value. But as we did back here in problem 59, notice that a number raised to the 4th power is going to be positive, and the absolute value of the positive is that number itself. So we're just going to write this as n to the 4th and claim now that this n to the 4th is the simplified form of this. So let's apply the rule of exponents to this one here. So in the numerator, let's just rewrite that as a to the negative 1/7. But in the denominator, we can actually combine these, right? 2 powers with the same base. We're going to add the exponents. So we're going to get a to the 2/7 plus negative 5/7, or let's write it like this, a to the negative 1/7 divided by a to the 2/7 minus 5/7. This will give us a to the negative 1/7 over a to the, now, 2/7 minus 5/7. 2 minus 5 is negative 3, so we're going to get negative 3/7. And now we have a division, right? We've got a division here, so we're going to subtract the exponent. Top exponent minus the bottom exponent. So we are going to get a to the negative 1/7 minus negative 3/7. And let's see, I'll go up here and finish this thing up here. This is going to be a to the negative 1/7 plus 3/7. A to the, now, negative 1 plus 3 is 2, so we'll get a to the 2/7. And we will conclude that that is the simplified form we're looking for.